We're doing Unit 5 Progress Check Part B. So we're going to look at 4, 5, and 6. So number 4, let f be the function defined by f of x equals sine of x plus cosine of x. What is the absolute minimum value of f on the interval 0 to 2? This is not a calculator question, so we need to think through this and work through this using calculus. Or you can actually use your knowledge of sine of x and cosine of x. So we want to find an absolute minimum. So absolute minimum will be found at a critical number or at an endpoint. And so we want to find the critical numbers. So the derivative of this is cosine of x minus sine of x. All right, we want to find that when that's equal to 0. So add sine of x to both sides. So we might look at this and be like, well, I don't know how to solve this. Well, this is really when sine of x is equal to cosine of x. So as you think through your trig, we should know when sine of x is equal to cosine of x. And that is when, and now we'll start general, that's at when some of the reference angles are pi over 4. Because if we think of a 45, 45, 90, or pi over 4, pi over 4, pi over 2, we know that opposite and adjacent are the same. And so, therefore, sine and cosine are the same because you would have x over x root 2 for sine and x over x root 2 for cosine. So we also need to know when sine and cosine are both the same sign, as in positive or negative. Well, in the first quadrant, they're the same sign because they're both positive, and in the third quadrant. So the time when sine x equals cosine x is when x is pi over 4 from the first quadrant and 5 pi over 4 from the third quadrant. All right, well, we can now use the candidates test to figure this out. I'm going to erase some of my work here so we can have room for this. So we want to plug in our endpoint, so 0. We want to plug in pi over 4. We want to plug in 5 pi over 4. And we want to plug in 2 pi. All right, so plugging this back into sine of x plus cosine of x. Hopefully you know your trig values. If you don't, remember you can draw triangles to help you with these. But and the other thing is if you know your sine graph. So sine of 0 is 0. Cosine of 0 is 1. So here's our sine graph. Sine of 0 is 0. Our cosine graph. So if you know those values. Sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2. Well, that gives us 2 root 2 over 2, or root 2. 5 pi over 4, it's going to be root 2 still, but they're both going to be negative, because in the third quadrant, both sine and cosine are negative. So this is negative root 2 over 2 plus negative root 2 over 2, which is negative root 2. And lastly, 2 pi. Well, 2 pi and 0 are the same angle, or they give you the same trig values, and so it's also going to equal 1. And so we're looking for the absolute minimum. The only one that's minimum is negative root 2. Sorry, the minimum will be a negative because negative root 2 is the only negative. So negative root 2 is our minimum value. It's not, we weren't looking for the value of x. We were actually looking for the minimum value. Number 5, let g be the function defined by g of x equals x squared minus x plus 1 times e to the x. What is the absolute maximum on the intervals negative 4 to 1? So this is going to be similar in that we have to think through this. Is this differentiable? and continuous, it is, this is a polynomial, that's a parabola times e to the x. They're both continuous, so when you multiply them, you'll get continuous. So we will have an extreme value. And so we are going to find the critical numbers first. And so we have to use the product rule. So x squared minus x plus 1 times the derivative of e to the x is itself, plus e to the x times the derivative of that first one is 2x minus 1. And we want to find when this is undefined or 0. It's not going to be undefined, so we're going to find when it's equal to 0. What's interesting is here we can factor out e to the x, and we're left with x squared minus x plus 1 plus, so factoring out e to the x, plus 2x minus 1, which makes things fairly nice here. So e to the x times x squared, we have some like terms in here, so the positive 1 and negative 1 become 0, and so we have x squared plus x. And that factors just a little bit more. So we want to know values that make e to the x equal 0, e to the x never equals 0. So no values of x make that equal 0. So x is equal to 0 or negative 1. And so we want to use our candidates test. We have the endpoint of negative 4, and then just going in order, we have negative 1. We'll give ourselves a little bit more space here. Negative 1, 0, and 1. So again, this is not a calculator question, so we just have to plug these in. So g of negative 4, so this is going to be negative 4 squared, which is 16. So we're putting it back into our original function. Negative 4 squared, which is 16, minus negative 4, which is the same as plus 4, plus 1, times e to the negative 4. And so this is 21. 16 plus 4 plus 1 is 21. And e to the negative 4 puts e in the denominators. So e to the 4th over 21. Well, don't know exactly what that's equal to. E to the 4th is going to be, well, so e is 2.7 something. So 2.7 to the 4th. Even just thinking 2.2, well, even 2 to the 4th is 16. So this is 21, not over 16. It's going to be bigger than 16. So we'll think about that later if we need to get a better estimate. Putting negative 1 in, so putting negative 1 into our function, negative 1 squared is 1, minus negative 1, plus 1, times e to the negative 1. Again, that e goes to the denominator. We have 1 plus 1 plus 1, so 3 over e. Putting 0 in, putting 0 in, 0 squared minus 0 plus 1, so this is going to be 1 times e to the 0, which is just 1. And then putting 1 in, we get 1 squared minus 1 plus 1 times e to the 1st. This is 0. So, sorry, this is 1. So 1 times e to the 1, so e to the 1st. And so e is 2.7 something. So it's not 1, it's not 3 over e, because 3 divided by 2.7 is just a little bit over 1. And then this is probably just going to be pretty close to 1, because e to the 4th is 2.7 to the 4th, or it's going to even be less than 1. So e is our answer. That's going to be the maximum. So that's B. All right, coming down to number 6. Looks like I typed in something here just to help us remember, and you don't have to read my bad handwriting. So number 6, the graph of the first derivative of f, or f prime, the derivative of the function of f, is shown above. On which of the following open intervals is the graph of f concave down? So we're given a graph of the derivative. We're asked about the original function f. We want to know when it's concave down. Well, a lot of times we think of second derivative when we think about concavity, but we can kind of back that up. And a good thing to know is if our first derivative is increasing, then the original function is concave up. If the original function is decreasing, then the original function is concave down. So really, let's just take our marker here, and we're not concerned with increasing or concave up. We're just talking about concave down. So we want to find when the graph is decreasing. So that it's decreasing from -5 to -3, and it's decreasing from x is 1 to x is 6. So looks like that's going to be A.